We're going to add a couple of new rules to our differentiation tool belt. These ones are a little more involved than our constant rule or our power rule, but they will come in super handy, especially as we move away from polynomials and learn about different types of derivatives. And when we talk about using these rules, if we look at our first example here, it's obviously a fraction, a rational expression. So we're thinking of fraction meaning division. So we're going to need a quotient rule to deal with this because we can't split this one apart nicely like we could when we had just a single term in the denominator. Or moving down sometimes, and maybe right now it'll seem like this is not super awesome, but it'll come in more, like I said. It just seems like it'll be a pain to have to expand this first, a trinomial by a binomial, and then apply the polynomial rule over and over again. So we're going to bring in two new rules. Our first one is the product rule, and it's for multiplying. So when you have two functions multiplied by each other. So ultimately, we could be looking at things like, x squared times cosine x, but that's not where we are right now, so we'll just disappear that, goodbye, and deal with what we know so far. So here we have two functions. We have this little one and that one, and they are multiplied by each other. And in our last class, we would just expand this and proceed to find the derivative from there. But we're going to do it a different way. So like I said before, we like to rename our functions so that we can think of them more easily. So we're going to call this one u, and we're going to call this one v. So we have a situation where we have u multiplied by v, a product. Likewise here, you could call this u, and this big long one could be v. So we're looking at u times v. I mean, if you want to get picky about it, you could say, like, actually, you're looking at cuv. But, I like to just bring the constant along as part of the u. It's easier for me. Whatever floats your boat. So here's our product rule, our formula. It's on your formula sheets. And basically, when we look at it, if you want to find the derivative of a product of two functions with respect to x, you're going to take the derivative of one and multiply it by the plain old other function, that's v, and then you're going to take the derivative of the second one and multiply it by the plain old first function, u. I find it confusing in this notation. I always like a good prime, so here we go. If you want uv prime, it's going to be u prime times v plus u times v prime. So you're flipping and flopping. And because it's addition, order doesn't really matter here. We'll see with the quotient rule that is much more important. And if our entire function, just like in example 1, is y equals, or f of x equals a function times a function, u times v, then here's our whole thing. Our derivative will be u prime times v plus u times v prime. So how do we set these up? Big fan of doing it with a little diagram. So what I always do is, just to keep myself straight, I call this one u, and I call this one v. This is entirely up to you. This is what I like. And then I'm going to put u prime down here and v prime down here. So first I'm going to take each, I'm not going to worry about multiplying out or anything. I'm just going to look at u. Looking only at this piece, what is the derivative of 2x plus 3? Well, we know it's going to be 2 because a constant has a derivative of 0, and the derivative of 2x is going to be 2 times x to the 0, which is just 2 times 1, 2. And likewise, v prime is the derivative of just what I see here. And we're going to say that that is going to be 5. Okay, so now I have all the parts that are going to go into my product formula, to use a product rule. So we're going to have y prime equals, and here's where we go, u prime v. So I like this also because it makes it look like a word search. I do the kind of crisscross, or almost looks like a cross multiplication, which it is. So here's u prime multiplied by v, 5x minus 1. And then I have to add according to the rule, and the second part will be, let's switch colors a bit, v prime times u. 5 times, I did not switch colors, oh I did, 2x plus 3. So here you've got it, but for full marks, of course, we know at this point we've learned enough that we're probably going to distribute and collect like terms. So finishing the math, I get 10x minus 2 plus, and then we're going to do the same thing, 10x plus 15, gathering like terms, 20x plus 13. And because this is a simple one, you could totally go back and just double check. On the test, we will ask you to use the product rule. And if we ask you to use the product rule, you do have to do it that way. But if we don't, anything's fair game. So let's just say we expanded first. We would have had 10x squared, and then our outside would have been minus 2 plus 15 plus 13x, and negative 3. And if we had just found the derivative of the polynomial, just using power rules, 20x plus 13, which is the same. We're going to do another example, and when I look at this one, unless you told me to, I would not want to use the product rule. I would want to distribute that 3x cubed in and then differentiate the polynomial. But it's a product rule example, so we're going to do it the way I say we're going to do it. Yay, us. Okay, so we've got u, and we've got v, and I'm just going to put the law over here, y prime equals u prime v plus v prime u, or uv prime, whatever order. All right, so the things we need to find are u prime and v prime. Go back to black here. U prime, I move the 3 and the exponent in the front and multiplies with the 3 that is always there, already there, so we're going to get 9x, and we drop down a degree squared. V is a polynomial, so I just go through 2x plus 4 and then nothing else. All right, now we're going to do our magic banana, kitty corner. Y prime equals 9x squared onto x squared plus 4x minus 3 plus our second one in green here, 3x cubed u onto v prime, 2x plus 4. Once again, we're in a situation we're going to end up distributing. 9x to the power 4, 9 times 4 is 36. Exponent law is on the x's, minus 27 x squared plus 6x4, moving into the second by distribution now, plus 12x cubed. Collecting our like terms, and I like to go in descending order because that's what got beaten into me. 9 plus 6 gives me 15x to the power of 4. 36 plus 12 gives me 48 x to the power of 3, and then we only have this one term, minus 27 x squared. Should you factor it? Meh, I'm fine with this. Having said that, if we were in a situation where we were looking for kind of critical points on a graph, yes, we would continue. But as we roll in, let's just stay here for now. If we want you to use a product rule with polynomials, rational expressions, we're going to force you to do it. The quotient rule, I fully expect that you will avoid it if you can. So you need to know when you have to use the quotient rule or when you have another option. And that means you need to be able to recognize what's going on in a function. So let's look at these three functions. So we're going to start with the first one here. We have 1 over root x plus 2. Do we need to use a quotient rule? Is this in the form function over a function that we can't deal with? No. This is the same as x to the power of negative 1/2 plus 2. And then we can just differentiate that using the power rule. Looking at the second example, can we split this apart? Like, could you make this x over 2 plus x over root x? Absolutely not. Let's give that the biggest red ever and say no, because that is not allowed. You cannot split apart that binomial in the denominator. That's just not how it works. So this one, you would use the quotient rule. Okay, in our third example, yes, we could use a quotient rule, or we have a second option. We could split this one because there's only one term in the bottom. So just like if you had 4 plus x over 6, you can make it 4 over 6 plus x over 6. You can split this apart 2 over x plus root x over x. You can recognize that this is the same as 2 times x to the negative 1 plus x to the power of negative 1/2, and that's just the same thing we did last class, and then you can use the power rule to go ahead. Options, take them if you can. Quotient rule's a bear. So here it is, and the top kind of looks like the product rule. There's like a bottom going on there too. You still have u prime v and u v prime, or whatever, v prime u, however you want to say it, in the top. But because there's a negative sign in between, order matters. You can't be mixing those up. You have to have u prime v as the first term in the numerator and u v prime as a second term. There's also this whole v squared that people like to forget about, and that's not the derivative. That's just, whatever that was squared. So they just get ugly fast. So let's see how it goes. Now, same thing, I'm going to kind of set it up, but this time I've got u here, and I've got v here. When I build my little box this time, just because of how it looks, my u prime will end up here, and my v prime will end up here. So just keeping track. So if u is 3x minus 7, u prime is going to be 3. If v, and you're not considering that v is a function in the denominator of a fraction, don't even think about where it is. Don't be like, well, that has to be the power of negative 1. We're not doing that. You're just looking at v as being 2x plus 5. All right, and the derivative of 2x plus 5 is 2. So once again, we're going to use that kitty corner rule. And now this time, if you set it up the same way I do, and always do the diagonal bottom to top first, or I guess what would you call what, quadrant, oh my goodness, quadrant 3 to quadrant 1, it'll work out for you. So that will give you u prime v, which has to go first according to the quotient rule. So here we go. U prime times v minus, it's different, v prime times u. And then we're going to put that all over, don't forget about this, v squared. So v is just here. It's not the derivative, it's just the function. Okay. We're going to clean up the top. I feel like I'm making a nightmare for myself here. So we're going to distribute 6x plus 15 minus 6x plus 14. I'm not going to change the bottom because, as I've mentioned before, you can see what's going on a graph much better when you leave the bottom in factored form. So although I'm doing all this work on the top, I'm just going to leave the bottom, the denominator, as is. And I forgot to call this 6, so that should have been 6, not 2, just looking back. Yeah, we'll leave it like that. I'll clean it up after. All right, so 6 minus 6, when I did everything correctly, is 0. So the x term is gone in the numerator, and 15 plus 14 is 29. And we have 2x plus 5 squared. So no fast way about this one that we know of yet. Second example of the quotient rule. So let's label who's who. We have u on the top and v on the bottom, which means that u prime and v prime kind of build over here. Okay, so looking at u, 4x squared minus 5x. For the first term, the 2 moves in front, multiplies with the 8, 8x, and then for the second term, just becomes minus 5. V prime, 3x plus 1, the derivative is 3. I'm going to write down my formula so we have it. Okay, so recognizing that this must be first. Oh, and we're going to be doing some binomial expansion. You're welcome. 8x minus 5 multiplied by 3x plus 1. Subtraction, and then we're going to throw in this bad Larry. 3 onto 4x squared minus 5x. And you don't have to organize it the same way I do. It's just like, I'm visual this way. Only when it suits me, I'm visual. V squared. Okay, So cleaning up on the top, there'll be many, many steps. 8 times 3 is 24. Outside is going to be plus 8 minus 15, gives me negative 7x. Last, minus 5. Moving to the second distribution, negative 12x squared plus 15x. And all of this will still be over v squared, which I'm just going to leave as is. Collecting like terms in the numerator, I'm going to end up with 24 minus 12. It's going to give me 12x squared. Negative 7 plus 15 is going to give me positive 8x. And minus 5. Quick check, it's always worth doing. Ooh, is that numerator, can I factor it? Do I have things that, multiply to negative 60 and are 8 apart? Thinking. No, not factorable right now, but always worth a check. So we're going to do this last slide. It's a bear. There's lots of things going on. Let's figure out what's going on. Yes, it would be easier just to multiply in that x squared into the binomial and then proceed with quotient rule only. However, the question is making us suffer, use the product and the quotient, so we have to do it all. Okay, so I have basically a situation where I have multiplication on top and then a division. So I'm going to deal with the multiplication first. I'm going to use u and v twice because whatever. You can use your own variables if you want, if it keeps it more straightforward. But because I'm just kind of resetting each time, I'm okay with it. So I'm going to take the top and I'm going to find the derivative of that using the product rule because they told me to. Going back to how product rule works, I have u and v, and I'm going to make u prime here and v prime here. X squared, the derivative is just 2x. And 1 minus 2x, the derivative, careful, that negative is in play still, is negative 2. Okay, so let's build it back up. U prime v. I'm just going to do both at the same time. U prime v, 2x onto 1 minus 2x. And then we're going to add, but we're adding negative 2x squared, so we can just combine that plus minus into a single sign. And then we're going to distribute 2x minus 4x squared minus 2x squared, and we get the derivative of the top, the numerator of the fraction from our original question is 2x minus 6x squared. Okay, we're going to take that up with us. I'm going to set up the way we do for the quotient rule. We have u over v. We just found what will be our new u prime, 2x minus 6x squared, and v prime is simply going to be 3. All right, let's build our monster. F prime of x. Okay, we are going to have to multiply 2x, awesome, minus 6x squared by u prime v, 3x minus 7, and we're going to have to subtract 3x squared, 1 minus 2x. And I like that now we're going to do the same distribution that we probably could have done at the start. And all of that will still be over 3x minus 7. So here we go. Let's do some expansion. Maybe I'll give myself a little more room. 6x squared minus 14x minus 18x cubed plus 42x squared. If you don't know what's happening, go back to the algebra basic stuff. Minus 3x squared plus, I still ran out of room, 6x cubed. Okay. And that's going to be, I forgot to put the square on, all of that over 3x minus 7 squared. Here we go again. Cleaning up the top. Negative 12x cubed plus 45x squared minus 14x all over 3x minus 7 squared. Gorgeous. And that's a product rule, quotient rule, and a product quotient rule.